Welcome back to Advanced Skills Learning. Most teams default to RAG for everything. It feels flexible, scalable, and safe. But in production systems, that assumption often breaks down. There are clear scenarios where fine-tuning is not just better, but simpler, faster, and more reliable. In this video, we'll break down when fine-tuning actually beats RAG, and how to make that decision correctly in real systems. This decision often determines whether your system scales cleanly or becomes increasingly complex over time. RAG became the default because it avoids retraining. You plug in a vector database, retrieve relevant chunks, and inject them into prompts. It works well for dynamic knowledge and reduces hallucinations. But this convenience creates a blind spot. Teams assume RAG is universally better, even when the problem isn't about retrieving knowledge at all. And that's where things start to fail. But this assumption ignores whether the problem actually requires retrieval in the first place. RAG depends entirely on retrieval quality. If your retrieval is slightly off, your entire output degrades. You end up stuffing more context to compensate, increasing latency and cost. Over time, prompts become bloated, noisy, and harder for the model to reason over. The system becomes fragile, not because the model is weak, but because the input is inconsistent. As a result, teams spend more time fixing retrieval than improving actual system behavior. Quick check. 2 seconds. What is the core weakness of RAG? A. More context always improves answers. B. Retrieval errors propagate to output. C. Larger prompts reduce latency. Keep your guess. The answer is B. Retrieval errors directly impact what the model sees, making them the root cause of many failures. Fine-tuning shifts the problem entirely. Instead of retrieving context at runtime, you embed patterns and behaviors directly into the model. The model no longer depends on external documents for every decision. This reduces variability and makes outputs more consistent. Importantly, fine-tuning isn't just about memorizing data, it's about learning structured patterns in how responses should be generated. This makes the system less dependent on prompt engineering and more on learned behavior. RAG starts breaking when your use case is repetitive. If users are asking similar questions over and over, retrieving context every time becomes wasteful. When the knowledge domain is stable, you're refetching the same information repeatedly. And if your system requires consistent outputs, like compliance or structured responses, RAG introduces too much variability. In these cases, retrieval becomes overhead rather than a meaningful source of improvement. Fine-tuning shines when outputs must follow strict formats or consistent reasoning paths. Because the model has learned the structure internally, it produces reliable outputs without relying on prompt engineering hacks. It's also faster, no retrieval step, no large context injection. For production systems where latency matters, this becomes a major advantage. This leads to systems that behave predictably even under slightly varied inputs. Think about systems like claims processing, support ticket classification, or policy interpretation. These are not retrieval-heavy problems. They're pattern-heavy problems. The same logic is applied repeatedly with slight variations. In these cases, fine-tuning captures the logic once and applies it consistently, instead of reconstructing it through retrieval every time. These systems benefit more from learned patterns than from repeatedly fetching documents. The real trade-off is not accuracy versus cost, it's flexibility versus stability. RAG is better when knowledge changes frequently. Fine-tuning is better when behavior needs to be consistent. The mistake teams make is choosing based on hype instead of understanding how often their data, and their logic, actually changes in production. Understanding this trade-off is what separates prototype systems from production systems. Quick check. 2 seconds. What really decides between RAG and fine-tuning? A. Fine-tuning is always cheaper. B. RAG is always more accurate. C. Use case determines the choice. Keep your guess. The answer is C. There is no universal winner, only a context-driven architectural decision. In real systems, the best approach is often hybrid. Fine-tune the model for consistent behavior and reasoning patterns. Then use RAG only where fresh or external knowledge is required. This reduces retrieval load while keeping flexibility where it actually matters. Instead of choosing one, you assign each technique to the problem it solves best. This layered approach allows you to optimize both performance and flexibility simultaneously. When applied correctly, this shift has system-level impact. Latency drops because you remove unnecessary retrieval steps. Prompts become smaller and easier to manage. Outputs become more predictable, which simplifies evaluation and monitoring. The system moves from experimental to production-ready, not by adding complexity, but by removing it. Over time, this also reduces operational complexity and debugging effort significantly. RAG is powerful, but it's not the default answer. Fine-tuning wins when your problem is repetitive, structured, and stable. If your system requires consistency and speed, relying entirely on retrieval will hurt you. The real maturity in GenAI systems comes from knowing when to stop retrieving and start learning. The key is aligning your architecture with the nature of your problem, not the latest trend. Small architectural decisions like this can have a massive impact on real-world system performance. Thanks for watching. If this helped you rethink your architecture decisions, like the video and subscribe to Advanced Skills Learning for more GenAI explainers, practical architectures, and quick quizzes.